An engineer student runs to the bus to catch a lesson with 6 meters over second speed. The bus stops when it arrives to the bus stop. The student thinks that he will catch the bus. When the distance between the student and the bus is 25 meters, the bus starts to move with an acceleration at 1 meter over second square. This has to be square. Sorry. Can the student catch the bus? If your answer is yes, after how many seconds does it catch? Okay, let's just start to the solution process. So, catching a bus means being at the same position for both the student and the bus. The student runs with constant speed, which this means xs for student equals xs0 plus vs0 times t. Okay, and for the bus, it runs with constant acceleration. And for xb is equal to xb0 plus vb0t plus 1 over 2 at squared. And as I told you, then to catch each other, x student should travel same with x bus. Then these two equations we should equalize with each other. xb plus vb times t plus 1 over 2 at squared. And now 0 plus v student times t should equal to xb plus 0 plus 1 over 2 at squared. Therefore, 1 over 2 at squared minus v student times t plus xb is equal to 0. Then t squared minus 2v student over a times t plus 2 xb0 a should equal to 0. Now we will have an equation that shows t vs over a parentheses 1 plus minus 1 minus 2 xb a over vs squared power of 1 over 2. The thing is, this right here has to be greater than 0. With another saying, then 2xb a over vs squared should be less and equal to 1. So now let's draw a graph that shows the acceleration and the graph should be for second and x in meters. So this is our student, and the bus is starting from here. So it will go like this. Again, we'll reach here. So let's say this is 10, this is 20, and this is 30. Okay, so there are two intersection points, right? This right here is for the bus catches the student. Then this right here is student catches the bus. And for this line, it's for students, and for this one, it's for the bus. So solving option A, Then 2 times 15 times 1 over 6 times 6 is approximately 0.83. This is less than 1, so the student catches the bus. Okay, and if we solve b, t is equal to 0 over 1 times, in parentheses, 1 plus 0 plus minus 1 minus 0.83 square, and from here we will have two roots. First one is 3.5 seconds and second one is 8.4 seconds. And solving for c, xb minus xb0 is equal to pbt plus 1 over 2 at square, and that is equal to 0. Plus 1 over 2 times 1 times 3.5 square, and this is the distance that the bus traveled. And solving for d, two xb0a over b s square, as I told you, is less than 1, so a is less than equal to bc square, bs square, 2xs, and this is equal to 36 over 10. So for d, what should the acceleration of the bus be in order for bus to not be catched? It has to be at least this. Thank you for listening. See you in next lesson.